all come under the system crashes, okay, or the system failures. So in that case, we say that we can recover our system with the help of the transaction logs. And there were three techniques in order to use the logs or to save the logs. That was undo, redo, and undo, redo logs. And we have seen that how we can use these undo, redo logs in order to recover the our database. So here is forward and backward recoveries. There are two types of recoveries. Actually, they are the same things like undo and redo, but we also give them name forward and backward recovery. What is backward recovery? Actually, in backward recovery, you do the follow the undo technique. Okay, the rule of undo logging. So what you do, you need to do some transactions undo. Okay. If you will apply the backward recovery, then maybe you will apply the undo technique on some of the transactions. And how you will work with that, that you will go backward in the reading of transaction. This is the way, okay, this is your log. So you will go in this way, okay, so backward. Read, start from the end and then go backward. And then you will undo, or undo mean remove the changes which were done by the transaction, and put that transaction into the undo list, and that will bring your database into a state where it was before the problem or before the system failure. Girls, can you hear me? Okay. So that is about the backward recovery. So basically, you just need to remember that in backward recovery, you will read the log from end to the start in a backward motion. And while you are reading the log, you will remove the changes done by any transaction. Okay. And this way, you will bring your database back to the situation or the state where it was before the system failure. On the other hand, um, On the other hand, the forward recovery is the opposite of backward recovery. In this case, you will read the log from start to the end, or basically from the checkpoint from where you want to where you want to start reading the log. So from that point, you will read the transaction log in a forward motion, and you will apply the changes again on a database that were uh, previously applied by some transaction. Okay, so basically you will redo some of the transactions, right? So you have to apply the changes done by the transactions again. So in this way, you will move on like this. This is your log, and you will move in this direction, the forward direction. Okay, you will start reading this way, and whatever the change you will find in the log, you will apply that on the database, right? And then this thing will bring your database on a update position. This is important to understand. This will bring your database to the up to date, and this backward forward recovery bring your database to the updated position, and the backward recovery will bring your database to the consistent state before the problem or before the system crash. Okay, so forward recovery is related to the redo, and backward recovery is related to the undo. So you need to remember this difference between them. Then the media failures. That all what I was talking about, like I said at the start, was about system crashes. Okay. But there is a problem, media failures. Media failures are, you know, media failure mean when you have a damage to your disk, right? Your hard drive or the disk where you have saved your log, or where your whole database was. Okay, that is more serious problem, because in the system crashes, we have the log, and our log is stored on some other place on the disk, right? It is not on the place where our database is. Actually, it is separately saved on a memory or the disk, right? So In that case, we can recover our database. But in case of media failure, where you have lost your disk, then that's mean you have lost also your log. So that is a more serious problem. Uh, in order to, because if you will lost your log, then how you will recover the database? So media failure is a more serious problem. So how to deal with this kind of problems? So basically they say that you have to make the backups. Okay, for this purpose, you need to make the backups. Backups is like a copy. Okay, you have your log on one disk, but you also keep a copy on other disks. Okay, so just in case if you lost or you have a damage to your disk, the main disk where the log is, you can get the copy of the log from the other disk. Okay, so this is the backups. Like you have one document, and if you make a copy of those, and just in case if you lost that document, so you can take the copy of that, and that's mean you can recover your document. So the same is the story with the database. In case you have a media failure, or media failure mean that if you have a damage to the disk where actually the log was, so if you will have the backup or the copy of the log on other disk, you can take it from there. So backups are needed to recover from media failure. The transaction log and entire content of the database is written to the secondary storage. This is what I have said, that all things that is related to the database and the log and everything, we also keep a copy on another disk. Time consuming and often requires the downtime. Of course, it's a time consuming task because you have to copy. Okay, let me wait. Okay, 1 minute. And now try if they can open. Is that okay now? It's the same link that you were using before the midterm. It is in your contents for Monday. Okay, anyway. So what I was saying that okay, yeah, it is time consuming to make the backups because you have to copy your all contents on another disk, and that will require some of your time. Backup frequency means that how many times or how often you need to make your backups. So they should be frequent enough that you do not lose your any important information or any updations from the database. Okay, and not so that frequent that like after every minute you are making the backups, because it takes a lot of effort and time, and that can also create the problems and inconsistencies in your database, right? So you have to schedule, or you have to make a timetable in order to keep this backup frequency. And the recovery from the backups from the media failure, of course, when you will have the media failure, you need the backups in order to recover or restore your database. So whenever there is a media failure, again I'm repeating, then there is a damage to your disk. That means you have lost your database and you have lost your log, everything. Okay, so now you need the backups, and backups are on the other storage medias. So we will use the logs stored on those backups. Okay, we will, of course, again we will use the logs, but they were stored on another storage media, and we will use them in order to apply the changes that were done before the system media failure. And if the transaction log is also, they are saying there are two possibilities, that if you have stored your transaction log on a secondary storage in the form of the backup, then use it for apply the changes. But just in case if you also lost your transaction log, uh, then you have to use the log which is placed on the backup, right? There are two possibility are they are saying that if there is a media failure and you have only lost your database, and log is still safe on your primary storage, so you can use that. But there is a second possibility that you also lost your log on the primary storage, so try to get the backup of your log from the secondary storage and then try to recover your database. This is the only option. Otherwise, if you have completely damaged your media failure and also you do not have the backup, in that case, it's very hard to recover from the media failures. Media failures is like that. Now, what is the problem? What is this? What she said, girls. Okay. You know, actually, you open your Blackboard maybe on the phones, and on the phone, you will not get the full access to the Blackboard. So you should have a laptop and then open the Blackboard on that. Blackboard is not completely designed for the phones. It's a very small app there. Doesn't have the complete functionality. It's okay. Yeah, because it's hard on the phones. Anyway, thank you. And so that's all for about the recovery part. The recovery chapter is done. We go back to our previous chapters where we have to, I think this one. I skipped few things from the previous chapter, so we will cover that today. Yeah, this one. Okay, for this, you need to remind or remember this if you remember. Okay, I did that before with you, but just for a revision, I'm repeating it again. That what we call it graph. Yeah. So you need to remember there are three kind of conflicts we have when the multiple transaction or concurrent transactions are working together. So basically, when this one you can remember, but normally in our graphs we do not giving you this kind of stuff. But anyway, there will be a conflict when transaction one, okay, I mean transaction number. I is the number, so we say it's one. So there will be a conflict. Conflict mean that it cannot be happen together. Okay, you understand what is the meaning of conflict? Conflict is like you cannot have the two classes at the same time. Okay, so the same conflict I'm talking about here. So when there is a transaction one and it is reading on data element X and it is writing on the data element Y, then there will be conflict. That's mean one transaction cannot work with two data elements on the same time, right? So this will be the conflict. The other conflict is when the two transactions, Ti and Tj, that's mean T1 and T2. There are two transactions, transaction 1 and transaction 2. So there will be conflict when both the transactions are trying to write on the same data element, which is X. Okay, X just a notation for the data element. So if transaction 1 is trying to update data element X and the transaction 2 is trying to update the data element X, then that is a conflict. Conflict means this cannot happen. Okay, so we have to stop it. This is not possible. Otherwise, there will be inconsistencies in the database. So this is the second type of the conflict. Then the third type of the conflict, when the two transactions, T1, T2, and they are doing this kind of stuff. So what they are doing, transaction 1 is writing on the data element X and transaction 2 is reading. So it is like this, transaction 1 is updating something on data element X and at the same time transaction 2 is reading that value. Okay, so there is a conflict because let the transaction 1 finish to update uh, data element X, then the transaction 2 should read that element. Otherwise, it will read maybe the dirty value or garbage value, right? So opposite is also like transaction 1 is reading and the second one, okay? Transaction 1 is reading data element X and transaction 2 is writing on the data element X, okay? So these are the opposite. So you can say these three are on the same data element. Okay, basically these three you need to remember. This in the graph we use this one. Okay, so you can say right is the you have the two transaction. Okay, in this case you have also two transactions. This is related to the two transactions. So when there are multiple transactions or two transactions are working concurrently in the system, then and the data element is also same everywhere, it is same. Okay, so you will say right, it is easier way to remember. Okay, right, read and read write, they all have the conflict, keeping in view that your data element is same, right? So write, read write and write read is always conflict when the two transactions are working with the same element. So this is the easier way to remember. And another case is where the transaction is one, okay, transaction is one, but the data elements are two, then there is also conflict. So these pairs you need to remember in order to work with this precedence graph. So in the precedence graph, I already told you that if you will have the cycles, that was also in your exam, if you will have the cycles in the graph, then it is not a conflict serializable. And if it has no cycle, then it was a It is a complex serializable. And what was complex serializable? Complex serializable mean that if you have a non-serial schedule like this this is not a serial schedule, right? It's not a serial schedule. This is a serial schedule. Serial, you remember, one after the other. So this is not a serial schedule, but by swapping or by changing the position of these instructions, non-conflicting instructions, if we can convert into a serial one like this, okay, then it is complex serializable, right? So to check, there are many ways to check that if we can make some non-serial schedule into serial. So one of them test is the precedence graph test. So if you will have the cycles in the graph, that's mean we cannot convert the non-serial schedule into serial schedule. But if there is a cycle, then we can convert the serial schedule into non-serial schedule, right? So this one I think we have already done. Let's do the example 2 today. Okay, so this is the schedule given here. Now how to read this one and how to make the graph from this one. First of all, here numbers are written 2, 1, 2, 2, 3, okay? Under the R and W, you can see the numbers. So from these numbers, you will get to know that how many transactions are working in this schedule, right? So we have 1, 2, and 3. That's mean there are 3 transactions in this schedule. So transactions are represented by the nodes. Okay. So I will make 1, 2, and 3. 3 nodes, right? Now I have to check the conflict. So I will start from the first one and this one. Okay. I will start with this one and then I will compare it with all of these and I will see if there is any conflict. Okay, so let's start from here. R2A, that's mean transaction 2 is reading on A is the data element, and R1B, transaction 1 is reading on the B. So we have seen that reading is never a conflict. Okay, there is no conflict because read, we do not have such pair that would have the conflict. So we will ignore that. Okay, when there is no conflict, don't do anything. Then the next one is this one. Okay, so this is transaction 2 is reading and transaction 2 is writing on the same data element. Okay, so still it is not a conflict because if you remember that slide, it's not, conflicting pair is not there. So we ignore this one as well. We come back here. Again, this is read, so just ignore it. No conflict. Again, read, no conflict. Come here. So now this is the transaction 2 is reading on the A and transaction 1 is writing on the B. So again, this is not a conflict because this one is working with the B and this one is working with the A. So no problem. That's okay. Now come back here, this one. Okay. So transaction 2 is reading on A and transaction 3 is writing on A. Okay. So now see this. Is it the same case or no? This one. Yeah. Transaction 3 is reading on A, X or A, whatever. And sorry, transaction 1 is reading on A and transaction 3 is writing on A. So it's a conflict, right? So this is a conflict. So whenever there is a conflict, we will draw a line from that to that thing. So it was 2 to 3. Sorry. So I draw a line. Okay, this. So I will draw a line from, because it is going from 2 to 3. So from 2 to 3, I put an arrow. So whenever you will find the conflict, you will place an arrow. And the last one is this R2 to A. W2 to B. So this is not a conflict. Okay. So this is done. Now I will do for the rest of them. Okay. Okay. Anyway, this is done. Now this one is finished. Okay. We will not check it again because this one is checked with all of them. Now the second one, this R1B. Okay. This R1B. Now check same way to the others. So R1B and W2B, no error, sorry, no conflict. So I just ignore it. This is read, no conflict. Again, read, no conflict. This is R1, W1, same transaction, reading, writing on the same element. So no problem, no conflict. Reading and writing different. Okay. Okay. R1B and W1B. No conflict because the same transaction is reading and writing on the same element. Then reading one, transaction one is reading on the B and transaction three is writing on A. Again, no problem because the elements are different. This one is problem only. Now onward, I will only draw the conflicting one, okay? Because it's too. Okay. So this one is only this and this is a conflict. Why? Because transaction 1 is reading on the B and transaction 2 is writing on the B. So this is a conflicting pair. Go and see in that slide, okay? So it is going from 1 to 2. So I will place a arrow here, okay? Now this one is finished. Go here and check with the all other. So quickly I see here, writing transaction 2 writing on A, reading B, no conflict. This is a conflict, okay? This one is a conflict because transaction 2 is writing on A and transaction 3 is reading on A. So it's a conflict. So it's going from 2 to 3. So we already placed it 2 to 3. So we will not do it again, right? So this one, writing and writing, but the data elements are different. No, just ignore, no conflict. This one is conflict. Because transaction 2 is writing on A and transaction 3 is writing on A again. Okay, so write is a conflict, but 2 to 3 I already, so you don't need to do it again. And this one is not conflict. So this one is finished. This one, R2, R3, no conflict, reading, R2 and W1. Yeah, it's a conflict. Look, this one. Transaction 2 is reading B and transaction 1 is writing on B. So read write is the conflict and it's going from 2 to 1. So you will place an arrow 2 to 1. Okay, before we had 1 to 2 and now it's 2 to 1. And after that, this one is no conflict and this one is conflict. No conflict. So this is cancel. Again, R3W1, no conflict. This one is no conflict and this one no conflict. No more conflicts, I see. No conflict. This one is conflict actually. This one, okay. But it is from 1 to 2. So 1 to 2 is already done. Okay, so this one is finished and there is no conflict between these two. So all are finished. So we check all of the pairs, and in the end we got this kind of picture, right? 1 to 2, 2 to 3, and 2 to 1 back. This is the cycle. Okay, this is the cycle. Actually, what is the cycle? When I want to show you here. Okay, cycle is like this. Cycle doesn't mean that something like this is a cycle. No, it's just a drawing. Okay, cycle mean you are going from one node, okay, from 1 to 2, and then you come back from that node. This is a cycle. Okay, for example, this is one way. Another way is also you go back to 2 and you come back to that same node. This is a cycle. Or you go here and then you come back here. These all are the way of cycles. Understand what is the meaning of cycle? So in our this case, what I was drawing, look, 1 to 2, 2 to 3, no problem, there is no cycle. But and then you came back from 2 to 1, then there is a, this is a cycle. Okay, so this means we have a cycle here. So this is not a conflict serializable. That means we cannot change this schedule into a serial schedule. Okay, so if I give you this kind of schedule, you have to make the precedence graph. Okay, and you have to check that if you have a cycle in the graph, then you will say that it's not a conflict serializable. And if you do not have a cycle like this, there is no cycle in this one. Okay, then you will say that it's a conflict serializable schedule. Clear? Any questions? Girls, any questions related to this? Is it clear? Okay, that's good. Okay, then we change the other. In the chapter 2, we left a few things. We'll go back there. Okay, here we left the concurrent SS anomalies. Okay, what are the concurrent SS anomalies? Like I told you, I think many times, that concurrent SS mean that when the multiple transactions are working together in the database or on the same database. So normally we have three famous, anomalies. Anomalies mean problems. Okay, so one is the lost update, inconsistent read, and dirty read. So one by one we see them. First one is the lost update. So you need to also remember that what kind of conflicts do they have here. So in lost update, we have the right conflict, the same pair that what I was doing there, in that slide of conflicting pair. So in lost update, basically because of the right conflict, this problem arises. What does it mean? That the one transaction is writing on the same data element and the another transaction is also writing on the same data element. Or happens that the one transaction, whatever it has updated on the data element, the another transaction will write on the same data element, and the first transaction will lost the update. That's why we call it lost update. Okay, like one user has updated the value of product numbers. Okay, and it was true that it was happened that the quantity of the products got changed. Another user also came and changed the value of the data element, let's say product, and it changed that. So the updation done by the user 1 will be deleted, and only the updation done by the user 2 will be kept. So in this way, the update by the user 1 was lost. Okay, so that's why we call it lost update. And it happened because of write conflict because both the transactions are trying to write on the same data element on the same time. So if the two transactions want to change the same columns or data elements, the second transaction will override the first one, therefore losing the first transaction update. Okay, this is the lost update. Here you can also see two tasks, T and T dash, like transactions T1 and T2, both modify the same data. Okay, what is the we should say that how it is happening. Two transactions T1 and T2, they are both working with the same data and both commit. It is not happening like that T1 rollback or it did not finish. No, both committed. So the final state shows effect of only T but not T. Okay. So in the database, the value of that column or data will show the effects. Effects mean the updation or the changes of only one transaction, not the other one, right? So this is like how it is happening in the lost update. This is what they are saying here. The same thing, overwrite. Okay. One girl writes something and the other came and write something on that. That's mean we will lost the written thing by the first person. Here is an example. Okay, there is a client 1 and client 2. So they are transactions. Okay, two users, they are working. So there is a table. Now it is in the code form. Okay, so try to understand. It's a SQL code. Customer. Customer is the table name. Okay, first try to understand this code, how it is written. So customer is the name of the table on which the user is working. So user want to update something in the customer table. So update is the keyword for the SQL and customer is the name of the table. Okay, or any table on which the user want to work. Now, where he want to do the update in this customer table. So he want to work with the rentals column or the data element. Okay, one column is always one data element in the databases or in the tables. Okay, so he want to update the customer table, and what he want to do, he want to change the column rentals, and in that he want to add +1. Okay, so set rentals equals to rental +1 where the customer name is Fred. So what it is basically saying that you have some table named customer where we have the multiple, um, columns, and in that you have the different values, different customers, and in that way you want to change the column where the customer name is Fred. 1 minute, I show you something. I don't have that. Anyway, so it's like a table. We have to draw. Okay, it's your database table, and you have different columns in that. Okay, you have columns in that, and then you have the rows in that. So here we have the ID. Here you have the customer name, this column, and then you have the rentals column here. Okay, so this is like your columns, and here you have ID, some customer name. So for example, for ID2 your customer name is Fred, and he has some value for the rentals, for example 3. Okay, so in this we are saying that go to the place where the name of the customer is Fred. So we come here, and go to which place? To the rental place. Okay, to the rental column. So we go to the rental column and add 1 into that. Okay, so the value is 3, so he added 1. That means he's saying 3 plus 1, and that will become 4. 3 plus 1, that is equal to 4. So this is the meaning of this query. Customer 2, he's doing the same thing. He's want to update the customer table, and he want to update the rental field for the customer their name is Fred. For example, we say to be changed, he says 2, okay? Otherwise you will confuse. So he is saying that add the plus 2. So what will happen? This will be done 4 and this will be 5, okay? This is 5. In the system, basically 3 plus 1 is 4. This is an updation. And then 4 plus 2 must be 6. Okay. But because they were doing this thing at the same time, so this client did not get the updated value of the rentals. That become now 4. So it only shows you 5, which should be actually 6. Understand? So that's mean here you have the lost data, lost update, because it was updated, right? So it was lost. That's why you get the wrong value and save the wrong value in your database. Two people attempt to rent 2 movies for the Fred from 2 different terminals. What happens? This happened that it will lost the data. Understand or no? Any question? Do you understand this or no? Girls. Okay. So this is about the law, right? Then there is a inconsistent read. Inconsistent read is the second type of anomaly. And what it says, one task sees the sum, but not all changes made by the T dash. There are 2 transactions are working in the system. Okay, transaction 1 and transaction 2, or the user 1 and user 2. User 1 is doing some operations or executing some transaction. Another user come and try to read some data from the incomplete transaction 1. This is your transaction 1, this is transaction 1, and this is transaction 2. Okay, this whole is transaction 1. So when the transaction 1 finished the 3 instructions, this transaction 2 came and tried to read some data from here. But still it is not complete because these 3 instructions are remaining, right? So this transaction 2 is trying to read the incomplete data from the transaction 1, and that will create the inconsistent read. Inconsistent read is like you are reading the wrong data. Actually it is not like that. Let finish this transaction and then read the data, but because it is reading in between of that, so you are reading the wrong data, right? um, so occurs when a transaction reads the several values from the database while the second transaction updates some of them. Now let's see here what they are saying. Update the product table and set the quantity. This is the sum column, quantity minus 5. Okay, whatever the value of quantity, for example 10. Okay, and where the product name is Gizmo. This is the name, like the same previous one. There is a table product and there are columns, product name, quantity, ID. So they are saying go to the product where the name is Gizmo and change the column quantity by minusing 5. Okay, it was not finished yet, and the client 2 came and it says select some quantity from the product. What is the meaning of this? It's saying that go to the table product and do the addition of all the quantities, this column in the table. But still it was not done here, because it is still saying update the product quantity where the product name is gadget and plus 5. Okay, so if 10 minus 5, it will be 5, and 5 plus 5 is 10. This will become 10. This sum will be the wrong, because it does not know this sum. It is taking it still 5, and this is 10, so it will tell you the 15, right? How? This 10 um, and this 5. Let's take it 15. So sum mean that take this quantity and this take this quantity, all the quantity in the system, okay? So, but it already minus 5 and it already plus 5, okay? So that will give you the wrong sum. The better example, because it's confusing one. Let me show you another thing. Let's take other values because a bit confusing here. We do not add 5 here because otherwise you cannot change the difference. I say to 10 here, okay? Here 10, and this was 20. Now done, okay? So update the product quantity. Quantity is 20 minus 5. That's mean it's become now 15, right? And the quantity of the gadget was about 30 here before. So this is 20 plus 30. If you see this, this is 50 and 15 and how much this? 30 plus 10, 40 and 15, how much? 45. Right. So what I'm doing here, that they have some product table where this product, for example, Gizmo has the number of quantity 20, right? And they're saying that minus 5. So that the remaining one is 15. And on the other one, they are saying that this is another product named Gadget and it has the quantity 30. So add, this is 50, I'm sorry, and add 10 into that. So this was 30 already in the system and this is 20 already in the system. So total we had 50 of them, right? We had the 50 of them. But what happened that when the client one or the transaction one finished this part of the transaction where the gizmo was 20 minus 5, it become 15. Okay, so this one is updated to 15. And another transaction came and it said that give me the sum like the all quantity of the product table. So this one is 15 and this one is 30 because it is not finished yet. So this will become 30 and 45, right? But if you run this portion that says 30 plus 40, 30 plus 10, that is 40 for this. So it becomes 40, right? And if you add these two, 15 plus 40 is 55, this one. Actually, this one is giving you 45, which is wrong. It should be 55. So it's giving you the wrong value, inconsistent read. Understand what I'm trying to say? because this one is reading the half updation, so it is getting the wrong value 45. Okay, but if it comes after this all should be performed and then this one come, then it will give you the right answer. But because it is coming in between of that, in the middle of that, so it is giving you the wrong value 45, which is actually 55. Okay, so this is the inconsistent read, and this is because of the write read conflict, because transaction 1 is writing and transaction 2 is reading on the same time. So it should not be happen that first the transaction 1 should finish its writing, then transaction 2 start reading. But it is happening wrong here. Transaction 1 is writing and at the same time transaction 2 and start reading the same data element. Look, quantity, this quantity. Okay, this set shows you writing. Okay, this keyword set shows you that you are writing on the database, and this select shows you that you are reading from the database. Remember that. Okay, set, if you will find the set in the code, this word, this mean you are writing on the database, and if you find the select, then this means you are reading from the database. Okay, this one. So this is the inconsistent read. Then dirty read. One transaction updates a database item and then the transaction fails. The updated item is accessed by another transaction before it is changed back to its original value. Here is the problem that two transactions are working together. It's also read-write conflict, first of all. Transaction when write something on the database, okay, again writing mean it does some updates on that database, and transaction 2 come and read that element. Okay, but transaction 1 transaction 1 rolls back. That's mean that it remove the changes that it has done previously, but transaction 2 has already read that data element and commit, right? So that's mean the transaction 2 has a dirty read. Understand? So this is like dirty read concept. If I have some example. Yes. This one. Okay. This is the transaction 1 and here is the transaction 2. Okay. Now this transaction is about what? Read the balance from some table. Okay. And then add 1000 into that. Ignore these values. Okay. Just read this. Read the balance, then add 1000 in the balance and then write the balance. This is the transaction 1. Then when it was finished, transaction 2 came and it read the balance and multiply it with 1.05, and then in the same time when it was doing this, it rollbacks. It's already read here, okay, before it rollbacks the transaction 1. It rollbacks and then the transaction 2 write the balance and commit. This is the transaction. See the sequence. Sequence is important. First, transaction 1, read the balance, do some updation, and also write it. Okay, still it is in the buffer. Transaction 2 came and read the balance from here, this one, and do some operation. It's still not written, it rollbacks. The transaction 1 rollback, and then transaction 2 write the balance and also commit. Now we see the problem here. For example, our starting point was 1000. Okay, we have the balance 1000. So read balance is 1000. Okay, and the balance plus 1000. So balance is 1000, we add another 1000, that becomes 2000, and it will write the balance, or it will update the balance to the 2000. Now the transaction 2 came, and it will read the updated value, this one. Yes, this one. Okay, so it will read the 2000, and then multiply 1.05, 2000 into 1.05, 2100, and it rollbacks. That's mean no operation, this cancel. But it already read the value, and it write the balance 2100 and commit. So where is the dirty read? This is the dirty read, because this one was done, but later on it was go back. Okay, so the correct solution should be like this. So this is the dirty read problem. Okay, you understand, this is the dirty read. In the real scenario, like when there is no dirty read, how it should be happen? Read the balance 1000, balance plus 1000, 1000 plus 1000, 2000, write the balance. So rollback should be here. Okay, so when this will roll back, it will read the balance 1000. It will read the balance 1000 here. Okay, that's mean now it's reading the right value, not the wrong one, because this one was rolled back and no changes. So now you see, read the balance 1000, multiply by 1050, and then commit. So this is the right value. Understand what is the dirty read? When you are reading the value from the transaction which do some updation, but later on it roll backs, then this is the dirty read. Understand? Any questions here? Girls, you have to do assignment on this. Okay, so please, if you have any question, ask me now. Here is the example of your inconsistent read. Okay, here is your lost update. First we go for the inconsistent read. What is that? This one. This one, okay. That example I was saying. Okay, update the product, set quantity minus 5, where name is shirt. We have this table. Okay, we have this product table, and we have the column ID, product name, and quantity. So we have the product name shirts, and we have 50 in our database, and then we have the dress, that is the 100 in our database. So this all, and then sequence is important again. It was not finished yet. Transaction 1, transaction 2 came, and some quantity mean that do the addition of all shirts and dresses from the product. And then this one, update the product, set quantity plus 5, where name is the dress. Now take the values. So we are saying update the product where name is shirt. So we go to the shirt column. Okay, first we go here, and then what we have to change, quantity. So quantity is 50. So quantity 50 minus 5 is equal to 45. Right? This is all good. But it was not finished yet, and it came here. And it says select sum quantity. Sum quantity mean this all sum. So we take shirt plus dresses. We need the shirt plus dresses quantity. But for the shirts, we have already updated here 45, right? So I took 45 for the shirts and the 100 for the dress, which is still not updated. So this will become 145. And then we come back here and we update the product table for the dress. Okay, dress, and the quantity is 100. So I did 100 plus 5 is 105. Yes. So now calculate this 45 and 45, 105 and 105. This is 150. But what this person got it? 145. Wrong value. Okay. The actual real value was 150. It was also 150 here if you see. Right. So he is getting 145. This is wrong. So this is inconsistent read. And then lost update. This one I think lost update. There are two transactions you can see here. Okay. Transaction 1 read x plus 10. Then the tip is always important. Read in a sequence. Don't read like this, one complete. No, it is not like this. First do this, then do this, then this, okay, and then this. So this is the sequence going on. So read x plus 10, transaction 1, transaction 2, read x plus 20, write x, read y, write x, read y, x plus 10. Okay, so this is all. Now let's solve it. This is lost update. Two transactions are working together and they are working with the x and y. So we have to see the actual values of x and y. So the starting value of the x and y is 50-50. Okay, so this is transaction 1, transaction 2, and here is the initial values for the data item x and y. So we read the x. So what is the read x? 50 from here value. Okay. Then you do some operation which says that's x plus 10, which is 50 plus 10. So you will get the 60. Yes. Now read x. So now the transaction 2 is reading x. So what it will read? 50 or 60? Answer me now. What it should read? 50 or 60? Girls. Why 50? Any reason? Actually, it is written there 50, and you are right, but there is a reason behind that. Why it is reading 50? Any answer? Hmm? Why it is 50? Because it was 60 also, no? It happened at 60 now here. So why we say that it will read the 50? Why not 60? Because it was not right here yet. There is no right. Right is later here. Okay. So that's mean it is just an operation done, not right in the memory. So still it is X. Okay. Transaction 1 did some operation, but Until it will not write, it will not update. In the dirty read, why it read the value? Because it was also written, it was also write. Okay, transaction also performed the write operation. So that's why in dirty read we were reading the updated value. But in the lost update, because it is not written yet. Okay, this is not written, right is here, so still it is 50. Understand why I'm reading? But if I keep this one here, for example, after this, if I say that write x, okay, then what you will read x, 50 or 60? If I write x here and then after that I read, yeah, then I will read 60. Okay, so keep in mind that always. So actually, because this is not here yet, so this is our 50, and 50 plus 20 is 70, over 70. And look, now x become here 70, and this is going to again write 60, because it's happening, it's in it, T1 is working separately in isolation. It doesn't know that there is some T2 in the, so it will write the 60. First it went 70 still, but it is not right, remember, but 70. Okay, and it will write 60, read y is no problem, it's 50, initial value 50, 50, and again write x here. This write x was 60 in the database. Actually, these are the problematic values. And this write perform here, and it changed the x to the 70. Okay. Then y is simple. Okay, because it's only read the y, so no problem. Read y 50, 60, 60, commit and commit. So this one is also committed and this one is also committed. And our x, y, no problem, because this one was only reading, it was not doing any writing or anything. So y is not a problem. X is the problem because both were reading and writing. Here it written x and here it written the x, right? But because of this, we have lost the this update. This update is lost. In actual, how it should be happen, see here, x is 70 and it is wrong. Actually, we have added 10 plus 20, which is, look, in x we have added first 10 and then we added 20, right? So answer should be 80, but answer is only 70 because we have lost the update here. We have lost the update here. Understand? So this is the wrong value. It should be 80 actually. Again, I'm saying that initial value of the x was 50 and first time in the transaction one we have added 10. So 50 plus 10 is 60, and then again transaction 2 added 20 into that. So that will be 60 plus 20 is 80. We have two updations, 10 and 20. Yes, we have two updations. One is with the 10 and one is with the 20. So 50 plus 30 is 80, not 70. But in the database value went as a 70, which is a lost update. So basically, which update we lost? Not this 21, but this 10 we lost. Got it? So this is our lost update. Any questions? Okay. this one is done. It's very important, so please do practice with this one. This all be done. It's the same conflicting pair, okay? Read, read, no conflict. Read, write is a conflict. Write, read is conflict. And write, write is conflict, okay? This I think already did it. And what else we left? Something we left in the chapter. I don't know which chapter. This locking we done or no? This portion we did or no? Girls, I think we did, na? This 2PL. I think we already finished with this one, right? Deadlock, we did it. Yes. Deadlock. Scheduler. I think this phantom problem was remaining. Yes. This I will do next time, okay? Phantom problem we did or no? No, we did not. This one is remaining. Okay, this I will do next time. In chapter 3, we are left with this one. Okay. Okay, that's enough for today, I think. Do you have any questions? Okay, give me your tennis, please. Al-Johra. Attend